Welcome back to the Machine Learning Basics series. Today we're learning two very important model evaluation techniques: train-test split and cross-validation. These techniques help us understand how well our model will perform on new, unseen data. Let's make it super simple. A model should not only perform well on the data it has already seen, it must also perform well on completely new data. That's why we use techniques like train-test split and cross-validation. They help prevent overfitting and give us an honest measurement of model performance. Train-test split is the simplest way to evaluate a model. We divide the dataset into two parts. The larger portion, usually 70 to 80%, is used for training. That means the model learns patterns from this data. The remaining part is kept aside and never shown to the model during training. This part is used as the test set. If the model performs well on this unseen test set, it means the model is generalizing well. Imagine you have a data set of 1,000 houses with price, size, location, and other features. You train your model using 800 houses. You test the model on the remaining 200 houses. If the model predicts the prices of these 200 houses accurately, it means the model is strong. One downside of the train-test split is that the result may change depending on how you split the data. If the test samples are unusually easy or unusually difficult, the model's accuracy might look better or worse than it truly is. This introduces randomness. To fix this problem, we use something more advanced: cross-validation. Cross-validation is a more accurate and reliable method of evaluating a model. Instead of doing just one train-test split, we divide the dataset into multiple folds or parts. The model is trained and tested multiple times, each time using a different fold as the test set. Finally, we take the average performance across all folds. This gives a much more stable and trustworthy result. K-fold cross-validation is the most popular form. If K equals 5, the dataset is divided into 5 equal parts. Each part gets a turn as the test set. This ensures every data point is tested exactly once. At the end, we average the results from all 5 runs to get the final accuracy. This is much more reliable than a single split. Let's take the house price example again. If you use 5-fold cross-validation on 1,000 samples, each fold contains 200 houses. The model is trained 5 times and tested 5 times. The final accuracy is the average of all 5 test scores. This makes sure your model is evaluated fairly. This comparison shows when to use each method. Train-test split is simple, fast, and good for very large data sets where even one split is enough. Cross-validation is slower, but far more accurate. It is the preferred choice when your dataset is small or medium in size and you need trustworthy results. If you have a very large dataset, train-test split is usually enough. But if the dataset is small or your model accuracy changes too much depending on the split, cross-validation is the best option. It ensures every part of the data is used for testing and results are balanced. This small visual summary helps remember both techniques easily. Train-test split uses only one test set, while cross-validation tests the model multiple times for a stable result. Thanks for watching the Machine Learning Basics series. Today you learned the difference between train-test split and cross-validation, two essential evaluation methods. In the next video, Day 18, we will explore bias versus variance, which will help you understand why models underfit and overfit. See you in the next session.